Welcome to the satellite communication course. So today we start with a model 4, a multiple access system, and in the multiple access system, so how your bandwidth is allocated to your transponder, that bandwidth and the power, how that bandwidth and power sharing is possible. That we will learn here. So in this multiple access techniques, already you people have learned that a frequency division multiplexing. Okay, so in which what various channels they have divided, or they are come to all the channels are divided with respect to whatever the band of operation, that is about frequency there. And you know that a TDMA, that is, it is about a time division multiplexing system. If all the incoming channels are separated with a frequency or are separated with a time here, so that is about a TDMA. So then we have another technique, that is about a code division multiple access system, that we learn here. So we learn here a frequency division multiple access, time division multiple access. Access means what? How that allocated band given to the channel. Okay, that we will learn. So now, if you simple consider that why this access systems required. So that's why we need to know about first basic model. So how your transponder work. So we say that earlier there are the multiple transponder in a satellite system. So we are getting a signal from the antenna to the transponder, and then appropriately whichever the signals came from the earth station, just like we say that is about a earth station here, it transmit the signal to the satellite, and then transponder respectively it convert that whatever the uplink signal, and then it will transmit to the downlink one. Now this is about a transmission of a signal from the earth station to the transponder. But here on the earth station, if you see that input signals of various carriers are combined together, and that will be transmitted here. Or we can say again here, various signals are combined at the transponder here at this particular antenna, various carriers, and then that input is given to the satellite there. Now then, a transponder we have that operate at a particular band. So if we consider that various carriers are propagating through it, n number of a carriers, and then all those n number of carriers is the input to the transponder, means there are the F1 to Fn various carriers. Means if you see the bandwidth, so that is about Fn minus F1, that is about the, you are saying that a bandwidth here, that is about the operating bandwidth. And for that, this transponder utilize all the carriers within that particular bandwidth. So for each and every carrier, separate band is defined. So bandwidth 1, bandwidth 2, bandwidth n, likewise. But overall bandwidth is whichever the range of the frequency operating for this particular transponder, that is the overall bandwidth. So now here, if you consider that in a multiple access system, so there are the sharing a resources. Sharing a resources, which means you can say that we have a number of users are there, more number of users are there, they are communicating, and that more number of users sharing the band, sharing the respective time, sharing the respective power. So the role of a multiplexing. or a multiple access means what? A number of users can be transmitted. So that's why it is saying that is about a multiple access system. Means various channels are multiplexed together and they are transmitting. And at the same time, they are separated by some band of a frequency that is called as a guard band in the case of a FDMA. Means here we can say that a various channels, various users use this particular transponder and they are using or they are sharing the transponder. So that's why a multiple access method or a system we say it is nothing but a sharing a whatever the resources. So means at this particular input side, if you see, so multiple inputs are or multiple signal sources from the different locations. They are reach at this particular place, or we can say that is about a base station or a earth station there, and they are transmitted. So likewise. So now this multiple access method is nothing but what? It is nothing but a sharing the resources. Sharing a resource. So now how these resources are shared? So means each and every channel they have a limitation regarding the bandwidth as well as they have a limitation regarding the power. Means we can send the signal with a limiting with a particular bandwidth and it has some limitations regarding the power because your satellite operate at particular power level and if that power goes beyond that particular power level then there may be a distortion. Means sharing the what? Sharing the bandwidth and sharing the power. So means we can say that that spectrum is shared by the different users or multiple users and again they share with respect to particular power there. So another way is about what? That is about a sharing a time. Now a time is allocated for each and every channel and then according to that they can use that particular band and they can transmit. So for a particular period of a time they will work or they will use the resources. So now this multiple access system that is sharing the bandwidth, sharing the power and sharing a timing according to that they have the different types of a multiple access system. So frequency division multiplexing, that is about a FDMA. If you share the timing, so that is about time division multiple access. If you share the power, that belongs to the code division multiplexing. So now these are about the three types of a multiple access system, and we'll see one by one. First, we start with a frequency division multiple access system. Now here the word is about a frequency division. So means we can consider that there is a division of a frequency. Now frequency division means what? A division of frequency means division of some particular bandwidth. So now each and every channel or any communication channel they are operating at certain bandwidth, or we can say that they operate at a certain frequency spectrum. Instead of a bandwidth, we can say that a frequency spectrum. So means every channel they have some limitations regarding the bandwidth. That limitations regarding the bandwidth means what? That particular specific channel is to be operate in the given particular spectrum only. So that is about a constant for a given specific channel. So right now, if you see that a mobile communication in a 4G, so allocated they have allocated some particular frequency spectrum or a bandwidth. So that is nothing but a constant to operate that various channels using that particular in that particular bandwidth there. So now that how that multiple users will use that particular frequency spectrum. So now to use that available frequency spectrum or available bandwidth, so then the channel can be divided in terms of multiple users, and that dividing that channel means dividing the frequency spectrum with a multiple users. So this particular method is called as a bandwidth sharing. The spectrum is divided into in a multiple users, and then we can use that spectrum for the multiple user. So now how that spectrum is shared, or how this particular spectrum. We just take an example here. So we have a spectrum allocation, and in that particular spectrum allocations, you can say that there are the multiple users they are operating with the various particular channel. Now you can see here. Now this is about a total spectrum allocated, and these are about the various carriers, or you can say that that complete radio spectrum that is shared by the n number of transmitter, and it has a carriers of a FC1 to FCN. With that carrier is about for the total spectrum allocated is n number of transmitters. So each n number of transmitters, and each transmitters they have the separate carrier, and this carrier separation it has a del f hertz. So now it is generally we are saying that a carrier are separated with the same equal bandwidth, but it is not necessary that the carriers are separated with a equal bandwidth. It is not necessary. But in case of a satellite communication, so the bandwidth and the power handling capacity of your transponder they have some particular limit. So means we can say that if channels are specified or this particular spectrum is specified, we say, but they have some particular limit for the transmission. Now, what are those limits? Now we can say that there is a upper link. Similarly, we have a downlink for the transponder or satellite. So means they have the limitations of a frequency because your transponder operate in the particular band of a frequency there. So they have the upper limit of a frequency. Similarly, in a transponder, amplifier are there. They are transmitting the signal to the earth station. When they are transmitting the signal to the earth station, they have the limitations regarding the power. So now this one is about a total spectrum we say for a one radio broadcast. So in the case of a satellite communication or a satellite channel, the bandwidth and a power handling capacity of a transponder, or you can say that power handling capacity of a power amplifier in the transponder, they have some particular upper limit. That upper limit is regarding what? Regarding the power and regarding the bandwidth. In the case of FDMA, if you see that sharing the bandwidth or sharing the a spectrum, sharing the bandwidth or sharing the spectrum with a limitations of this whatever the transponder output power, or you can say that amplifier power. Now in the case of, if we say here, we have the n number of channels, and that n number of channels, they have a limitations regarding the complete power, as well as they have limitations of the bandwidth. Now we'll talk about the, what about the power limitations there, because if you see that here we say that there is a limitations of the frequency there for each and every channel. But when we transmit the signal, we say there is upper limit and all. So now in that case, there may be interference occur, and that interference is regarding that given particular channel or adjacent channel. To avoid the interference of that particular adjacent channel, so we need to use a separate band or a separate operating frequency band for your channel. I'll take an example here. We have the a carrier F1, say F2 now, F3, F. Now this particular band here, each and every band, they are separated with some particular guard band. Now this is nothing but we can say it is about a guard band. Now if you consider the here, that is F1, F2, F3, and for the specific channel, so this one is about a bandwidth here. It is about the operating bandwidth. So now if you consider here, we say this is about the bandwidth, but usable bandwidth is different here. Usable bandwidth is a smaller, and the gap between this particular channels, or you can say that a spectrum, okay, so that gap is nothing but a guard band. And why this guard band is required? To avoid the overlapping of the adjacent channel. So means there is, that's why that guard band we say it is just like a, you work as a limitations of a bandwidth, means this particular channel's spectrum is limited because of this particular bandwidth there. But if you consider that the total four channels we see right now is about a complete available bandwidth, and that available bandwidth for each and every channel f1, f2, f3, that is carrier, and bandwidth is about the what, bandwidth 1, bandwidth 2, bandwidth 3, bandwidth 4. But in each and every bandwidth, because of that a guard band, the available bandwidth, whichever the available bandwidths are there, that available bandwidths are not used efficiently. Means you can say that a transponders use or inefficient use of a available bandwidth or available transponder bandwidth, and that is nothing but the total available bandwidth here, and this particular guard band, and that guard band is nothing but that wastage of a spectrum there, and because of that wastage of a spectrum, it reduces the capacity of a FDMA system. Now earlier we say here it has a, they have a separation of carrier here, but in that case we require a specific guard band. So using this particular guard band, so available bandwidth is reduced. So that's why that channel capacity is reduced. Now, if you consider that a difference of this FDMA and FDM, so in the case of FDMA here, so FDM is just like what happened. It just combined. It is just combined a signal from the different sources of a location at a different location, and then it forms a multiplex channel. Okay, it combined the multiple sources at a multiple location, and then it forms one particular multiplex channel. But in the case of FDMA, different location share the common transmission medium. Okay, here we can say that a different location share the common transmission media. Now we can use a transmission, or we can say that different locations share the common transmission media. So in which we can consider that there may be analog voice channel or a digital voice channel. In the case of a FDMA, if you consider that there will be a analog voice signal, so then what happen? We can say that a analog voice signal that are modulated with FM. Okay, analog voice signals are modulated with FM. So then we'll get that FDM, FM, FDMA system. If it is a digital PCM coded voice, then This is about just like a digital signal or digital coded PCM voice signal, and that will be multiplexed with a PSK modulation. Then it will result with a PCM PSK FDMA system. This one is about, you can say, analog system. This one is about a digital system. Now we will learn here how this intermodulation distortion occur in FDMA. So now earlier we say that FDMA they have a limitations for the bandwidth and limitations for the power. Power means for your output amplifier. That is about the output amplifier at a transponder, because whichever the power amplifier is used in the transponder, the role of that power amplifier in the transponder, it will combine the signals and then it will amplify. Okay, so this role is what? Power amplifier combine the signal and then amplify. Now when we say that it combined a whichever multiple signals there and then amplify, then they have the limitations regarding that output power of the amplifier. So in the satellite or in the transponder, so there are the two types of a power amplifier it used. That is a solid state power amplifier and a traveling wave tube amplifier. We learn in detail that that is about a solid state power amplifier and traveling wave tube amplifier. Now they are about the power amplifier is used. So SSPA, or you can say that TWTA, traveling wave tube amplifier. Now all these particular amplifier, they have a limited power handling capability, because if we use a solid state amplifier, so they have a limitations because the devices work at particular power or particular temperature there. Similarly, they have here limitations in the case of a traveling wave tube amplifier. They have a limitations regarding the power. So means we say that all these amplifiers have a limited power handling capability. But if you consider that to operate this particular power amplifier at a maximum output power, then this amplifier is to be operated in a saturation mode. But if you consider that if this amplifier are operating in the saturation mode, then that power amplifier operates in the non-linear region of the input output transfer curve. Now we'll see the a curve here regarding that output and input. And if you see the curve, and then you can see here they have some limitations regarding that output power. At this particular point, if you consider here, This one is about a output power at a saturated point, power at a operating point. Now this particular point, if you see here, this is nothing but a S, that is about the saturating point, and this is nothing but a O, that is a amplifier operating point. Then we can say that amplifier operating point, and then we can say that amplifier saturation point. And then this one is nothing but what, a input operating point and input is saturated point. And difference between these, that is a back off. This is called as a input back off, and this is called as a output back off. So if you consider that a P output, that is about the output. PO is nothing but a output power, and SAT means what? A saturated. So this one is about a saturated output power, and this is about a what? Output power, power output at a linear operation. Now this is about a linear operation. This is about a output power. So similarly, if you consider that, so this one is about what? A input power at a saturated output operation. Saturated operation. Input power at a saturated operation. And this one is nothing but what? A input power at a linear operation. This is about the input power at a linear operation. And this is nothing but what? A output back off. And this one is nothing but what? A input back off. So now this particular curve, if you see that it has a saturation point as here. So from this particular saturation point, we see that we have a saturated input power and a saturated output power. So means at that saturation point, it has a corresponding input power and the saturated output power. And that is nothing but what? A maximum attainable output power of this particular amplifier. So this is about, this figure is just showing you that a transponder input output back off. So means your output that amplifier is to be operate in the given particular region. Now this intermodulation distortion, or you can say that intermodulation products, when these intermodulation products occur, if a multiple carriers are present in the input, okay, if the multiple carriers are present in the input, then the amplifier will produce the intermodulation products at the output. Means that amplifier, we can say that it operate in a, if it is operate in a linear manner, no problem. But that particular amplifier produces the intermodulation products when it operate in a non-linear region. That's how you can say that a non-linear amplifier that will produces the intermodulation products. But in the case of the amplifier, saturated amplifier, now that is about a saturation point. So generally what happens, this particular amplifier, it generates a, or it behaves like a mixer. It generates a sum and difference of all the input pairs of the frequencies and their harmonics there. So means how it generated there. Means if you consider that, so some particular a transponder, we have the it, a nonlinear transponder. If you consider here, this is nothing but a nonlinear transponder. And for this transponder, we have F1, F2, up to Fn. These are the various input carriers. These are the input carriers. And we'll get that output carriers. And that is nothing but what F1, F2, Fn plus intermodulation products, IM products. Now this is about a behavior of a transponder. Generally we can say that the saturated amplifier, okay, at this particular saturated point, amplifier saturation point here. The saturated amplifier behaves like a mixer. Okay, so then it generates a sum and difference component. Means here output is nothing but what output carriers, whichever the input carrier. Plus, in addition to that, it has some IM products. That is called as the intermodulation product. But what happened that whatever the intermodulation products are generated, that IM products, those who fall within the signal band, which act as the interference, this IM product act as the interference, and that's why it degrades the performance of the your channel. That's why these IM products, those fall within the signal band or operating band, then they will act as the interference and they will degrade the performance of the channel. If you consider that the input output characteristics of this amplifier, nonlinear amplifier, so that is just like we are expressing in terms of a input power and a operating input power and a operating output power there. But in the case of this here, if you see that, so there are the multiple input carriers, and that multiple input carriers generate that multiple output carriers, and these output carriers contains what original carriers F1 to Fn and a various IM products. Now these IM products, it just degrade the performance of your channels there. And it just what we can say that these IM products will act as a interference there. Now how this F1 and F2 plus IM products, how your output spectrum will okay, how it looks like. Okay, so we'll see here. Now we have just we'll take an example of a input carrier F1 and F2. Only F1 and F2 will take. And now this particular spectrum, we say that this is nothing but a F1 and this one is nothing but the F2. Now these IM products are what? That are the multiplication factor, or these are just like a spectrum. Now if you find out the value of all these 4 F2 minus thrice of F1, so it is nothing but what? Sorry, twice of F2 minus twice of F1. This one is nothing but what? Twice of F2 minus F1. Now F1 twice of F2 thrice of F1. You can see that twice of F2 thrice of F2 4 of F2. Okay, likewise. Similarly, we can write here 4 F1 minus thrice F2. This one thrice of F1 minus twice of F2. This one twice of F1 minus F2. Now this is about the input output spectrum, and that will show you the intermodulation products. These are nothing but the IM products. These are the IM products of what? Of the input carrier F1 and F2. For this input carrier F1 and F2, so these are the intermodulation products generated. Now to avoid this generation of IM products, then we need to see that that amplifier is to be operated in the linear region. And then we can satisfy that input, whichever we can consider that. To avoid that particular IM products, we need to see that that amplifier is to be operated in the linear region. So now how this can be occur? So whichever the power transmitted by the transponder, they have some limitations regarding the power transmission. We need to restrict to this particular transmission of the power there.